Electrostatics. Electrostatics is a branch of physics that deals with the study of charges at rest. इलेक्ट्रोस्टैटिक्स के अंदर जो है आप यहाँ पे जो चार्जेस हैं उनको रेस्ट पोजीशन में जो है स्टडी करते हैं। यानी आपके पास जो है वो बेसिकली दो टाइप के चार्जेस होते हैं, एक जो है वो पॉजिटिव और दूसरा जो है वो नेगेटिव है। इसकी बहुत सारी एग्जांपल्स हैं कि किस तरह से हम जो है वो चार्ज को क्रिएट करवा सकते हैं। चार्ज जनरेशन के भी जो हमारे पास मैकेनिकल मेथड्स हैं वो भी जो है वो फिजिक्स स्टूडेंट्स जो है वो इस वाले से उनका जानना बहुत ज़रूरी है। जब आप कंघी करते हैं बालों के अंदर, व्हेन यू आर कॉम्बिंग योर हेयर, तो आप वहाँ पे जो है वो देखते हैं कि अगर थोड़ी देर के लिए आप अपने बालों में से कंघी को गुजारें तो जो आपकी कंघी है या कॉम्ब है उसके साथ बाल जो है वो उसकी तरफ लपकते हैं अगर आप करीब लेके जाते हैं। तो असल में होता ये है कि जब दोनों चीज़ें आपस में रगड़ खाती हैं, ये जो आपका कॉम्ब है और आपके हेयर हैं यानी बाल जो है, तो उसके नतीजे में एटम्स के अंदर जो है वो चार्जेस जो है वो डिस्टर्ब होते हैं। यानी इलेक्ट्रॉन जो है वो किसी एक एटम को छोड़ के दूसरे एटम की तरफ जो है वो चला जाता है, जिसकी वजह से यानी कॉम्ब के एटम से अगर इलेक्ट्रॉन जो है वो छोड़ के बाल के एटम की तरफ गया तो अब जो कॉम्ब का एटम था उसके ऊपर पॉजिटिव चार्ज आ जाएगा, और इसी तरह जो आपका हेयर है उसके जिस एटम के साथ वो इलेक्ट्रॉन जाके अटैच हुआ उसके ऊपर जो है वो नेगेटिव चार्ज आ जाएगा। इसी तरह देयर आर नंबर ऑफ मेथड्स टू क्रिएट charges. So basically there are only two. Here it is the definition of electrostatics, that branch of physics which deals with the study of charges at rest under the action of electric force is called electrostatics. अब यहाँ पे ये चीज़ स्टूडेंट्स को जो है वो समझनी चाहिए। मान लें कि आपके पास जो है वो दो चार्जेस यहाँ पे पड़े हुए हैं, एक आपके पास जो है पॉजिटिव चार्ज है, एक जो है वो नेगेटिव चार्ज है। तो उन दोनों चार्जेस के दरमियान अगर वो ऑपोजिट चार्जेस हैं, इट मींस वन ऑफ द चार्ज इज़ पॉजिटिव एंड अदर वन इज़ नेगेटिव, तो अल्टीमेटली दे विल अट्रैक्ट ईच अदर, एंड इफ़ द चार्जेस आर सेम दे विल रिपेल ईच अदर। सो विद व्हाट फोर्स दे विल रिपेल और अट्रैक्ट ईच अदर, किस कुव्वत के साथ वो एक दूसरे को जो है वो अट्रैक्ट करेंगे या रिपेल करेंगे, उसी को हम जो है वो यहाँ पे जो है वो कूलम फोर्स भी कहते हैं, और इलेक्ट्रोस्टैटिक्स जो है वो भी इसी स्टडी का नाम है। ओके, लेट अस मूव फर्दर। In electrostatics, first of all we should know some basic terms which are related to the electrostatics chapter and also Coulomb's law. So the first one is electric charge. What is electric charge? An intrinsic property of fundamental particle which takes part in conduction process is called electric charge. Either they repel or attract each other. As I said earlier, that when two objects consisting of atoms come across each other and drag on each other, या आपस में जो है रगड़ खाते हैं, तो उसके नतीजे में उनके एटम्स के अंदर जो इलेक्ट्रॉन्स हैं वो एक एटम से छोड़ के दूसरे एटम की तरफ जाता है, जिसके रिजल्टेंट के तौर पे क्या होता है कि आपकी उस एटम के ऊपर जो है वो चार्ज जो है वो आ जाता है, और उसी को हम जो है वो यहाँ पे जो है वो इलेक्ट्रिक चार्ज भी कहेंगे। अब यहाँ पे जो है इस इलेक्ट्रोस्टैटिक्स के अंदर जो है हम पॉजिटिव और नेगेटिव चार्जेस की बात करते हैं, तो दो ही तरह की इनके दरमियान जो है फोर्सेस एग्जिस्ट करेंगी, फोर्स ऑफ अट्रैक्शन और फोर्स ऑफ रिपल्जन। यहाँ पे जो अगली बात है वो ये है कि आपको एज अ फिजिक्स स्टूडेंट्स यू शुड नो दैट व्हाट आर द टाइप्स ऑफ आर काइंड्स ऑफ चार्जेस। सो देयर आर ओनली टू काइंड्स, दैट इज वन इज पॉजिटिव एंड द अदर वन इज नेगेटिव। प्रोटॉन को अगर हम कह लें तो वो पॉजिटिव चार्ज यहाँ पे कह सकते हैं आप उसको, इसी तरह इलेक्ट्रॉन को जो है आप नेगेटिव चार्ज कह सकते हैं। केमिस्ट्री के अंदर भी जो आप इस चीज़ को पढ़ते हैं। इसी तरह ऐसे यूनिट जो है वो चार्ज का क्या बनेगा, एंड दैट मीन्स every quantity in physics has some units. So does the charge. It has its unit as Coulomb. Okay. Electric force. Now this is the basic definition of electric force, which is the force which hold the positive and negative charges to make up atoms and molecules is called electrostatic force or electric force. ह्यूमन बॉडी जो है वो भी हमारे पास इलेक्ट्रिक फोर्सेस की वजह से जो है वो उसका एग्जिस्टेंस है. अदरवाइज if this electrostatic force is not there, then it is not possible that our body will maintain its physical structure. हमारे जो एटम्स हैं, हमारा जो बॉडी है वो नंबर ऑफ एटम्स से मिलकर बना है, तो उनके दरमियान जो बॉन्डिंग है दैट इज़ बिकॉज ऑफ दिस इलेक्ट्रिक फोर्स. तो हम अपने जिस्म का एग्जांपल भी जो है यहाँ पे दे सकते हैं. इलेक्ट्रिक फोर्सेस की दो तरह की टाइप्स होंगी, because there are only two types of charges, positive and negative. So the forces will also be only of two kinds. That one is repulsive if the charges are same. If the charges are same, it means if both are electrons or protons, then there will be a repulsive force. And there will be attractive force if they are different. That means if one of the charge is electron and the other one is proton. Okay. So these are some basic terms. Every physics student, when he or she is dealing with the chapter electrostatics, he must know these terms, that electric charge, kinds of charges, what is that's a unit, and electric force, also the types of electric forces. Okay, next the question which come into exam and often it is put by the examiner in the final exam, that is Coulomb law. Coulomb law was presented by our, I should say that it was given by military engineer Charles Coulomb, and that is why we call it Coulomb's law. In fact, Charles Coulomb, what he did, that was the measurement of force between the two charges. As we have learned that if there are two charges, then there is a force of attraction or force of repulsion between these two charges. So Coulomb did a great job, that he found a formula to measure the force between the charges, whether it is force of attraction or force of repulsion. So it is a statement of Coulomb's law, that is the force of attraction or repulsion between two charges is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between them. यहाँ पे आप मान लें कि आपके पास दो चार्जेस हैं, एक आपके पास जो है वो पॉजिटिव चार्ज है, एक आपके पास जो है वो नेगेटिव चार्ज है. तो उन दोनों का अगर हम प्रोडक्ट ले लें, इट मीन्स कि हम क्या करें कि Q1 और Q2 को जो है आपस में क्या करें, मल्टीप्लाई करवा दें, और इसी तरह जो उन दोनों के दरमियान डिस्प्लेसमेंट है जिसको हम R कहेंगे, उसका स्केयर ले लें. तो जो प्रोडक्ट होगा चार्जेस के मैग्नीट्यूड का, वो तो फोर्स ऑफ अट्रैक्शन या रिपल्जन के डायरेक्टली प्रोपोर्शनल होगा, लेकिन जो आपका डिस्टेंस होगा चार्जेस के बिटवीन, वो उसका स्केयर लेके हम उसको जो है वो इन्वर्सली प्रोपोर्शनल करेंगे. और ये जो R है, ये हमने चार्जेस के सेंटर से जो है वो कंसीडर करना है. अगर दो चार्जेस है तो उनके सेंटर से लेके दूसरे सेंटर तक जो है, दूसरे चार्ज के सेंटर तक हम उसको जो है वो यहाँ पे लेके जाएंगे, और यही डिस्टेंस जो है हमारा डिस्टेंस बिटवीन द टू चार्जेस होगा. और अगर इस दोनों एक्सप्रेशन को कंबाइन करें तो फाइनली वी विल गेट F is equal to K Q1 Q2 over R square. K is a proportionality constant, also called as Coulomb's constant. Its value is 9 cross 10 raised to the power 9 Newton meter square per Coulomb square. This is the numerical value of K constant. So the next point is on which factors the value of K depends. In fact, the value of K depends upon two things. One is the system of units. What does this mean? It means that in which units we are measuring this charge and in which units we are measuring this length. मीटर, सेंटीमीटर, किलोमीटर और चार्जेस जो है उनका हम जो है वो कूलम में हम ले रहे हैं तो उसी टर्म में आएगा ये इसका K की वैल्यू। इसी तरह फोर्स जो है वो अगर ऐसे ही सिस्टम के अंदर हम लेते हैं तो इसका यूनिट न्यूटन होता है। तो इन यूनिट्स के ऊपर जो है K की वैल्यू जो है K जो है वो डिपेंड करता है। इसी तरह नेचर ऑफ मीडियम, तो यहाँ पे ये फिगर है तो इसमें आप ये देखें कि ये पॉजिटिव चार्ज है आपके पास और इसी तरह ये नेगेटिव है। तो इन दोनों चार्जेस के दरमियान जो मीडियम है, अगर एयर है तो उसके ऊपर ये इसकी वैल्यू अकॉर्डिंगली K की डिपेंड करेगी। और अगर यहाँ पे रबड़ मटेरियल है, कोई प्लास्टिक आपने प्लेस करवा दिया, if you place some kind of wood between the two charges, then medium's nature will also change and K's value or K will also changes accordingly। तो ये बात वो यहाँ पे करता है कि on which factors K depends। तो ये एक तरह से आपका शार्ट क्वेश्चन भी जो है वो बनता होता है कि what are the factors on which value of K depends। अगर यहाँ पे मीडियम जो है वो हमारे पास फ्री स्पेस हो तो फिर जो है K हमारे पास मैथमेटिकल जो उसकी फॉर्म है दैट इज़ 1/4 पाई एप्सिलॉन नॉट। 4 पाई कांस्टेंट है, एप्सिलॉन नॉट जो है वो परमिटिविटी ऑफ फ्री स्पेस है और ऐसे यूनिट्स के अंदर जो है इसकी वैल्यू 8.85 10⁻⁻12 पर न्यूटन पर मीटर स्क्वायर कूलम स्क्वायर जो इसका रिजल्ट बनता है। ये एक न्यूमेरिकल वैल्यू है। एज अ स्टूडेंट यू मस्ट remember this value and also the value of K constant। अब इस सारे को सॉल्व करने के बाद आपके पास ये रिजल्ट आता है और अलहदा से अगर आप सेपरेटली एप्सिलॉन नॉट की वैल्यू को फाइंड आउट करना चाहें तो उसकी वैल्यू ये वाली बनती है। अब यहाँ पे ये हमारे पास जो है वो कूलम्स लॉ की स्टेटमेंट बन जाती है अगर K की वैल्यू को हम यहाँ पे पुट कर देते हैं तो, यानी ये इन्हांस्ड फॉर्म है आपकी जो है वो एक्सटेंडेड फॉर्म बनती है कूलम फोर्स की when we put the value of K। इसको जो है हम मैथमेटिकल फॉर्म कहते हैं। आपका जो कूलम लॉ है, बेसिक जो इस कूलम लॉ के अंदर आपके पॉइंट्स हैं वो यही हैं कि फोर्स डायरेक्टली प्रोपोर्शनल है मैग्नीट्यूड ऑफ चार्जेस के और इसी तरह परपेंडिकुलर इनके दरम्यान जो डिस्टेंस है आर चार्जेस के उसके इन्वर्सली प्रोपोर्शनल है और फिर उसका स्केयर भी लेना है। और इसी तरह K डिपेंड करता है दो फैक्टर्स के ऊपर। K का जो फार्मूला है दैट इज 1/4 पाई एप्सिलॉन नॉट एंड देन द फोर्स ऑफ ट्रैक्शन और रिपल्जन व्हिच इज कॉल्ड कूलम्स फोर्स विल बिकम 1/4 पाई एप्सिलॉन नॉट Q1 Q2 over R square। Okay, finally in Coulomb's law we have to define the vectorial form of Coulomb's law, that is if there are two charges Q1 and Q2, in figure these charges are shown Q1 and Q2, then we have to define that what will be the direction of force between these two charges। So if the Q1 charge is putting force of repulsion or attraction on charge Q2, then we will write it as R21। R21 means that force from charge Q1 is exerted on charge Q2, force exerted by charge Q1 on Q2। R is a unit vector which describes the direction of this force, and in this case in reaction when Q1 puts force or exerts force on Q2, then in reply जवाब में जो है आपका Q2 क्या करेगा वो भी इसके ऊपर उतने ही अमाउंट की फोर्स लगाएगा, लेकिन अब डायरेक्शन उसकी जो है वो चेंज हो जाएगी। When Q2 exerts force of attraction or repulsion on Q1, then it is written as F12 and its directional vector is R12, force put by charge Q on charge Q1। So this is vectorial form। You all know that in physics force is a vector quantity, so we have to define its direction when we are finding the force of attraction or repulsion between the two charges. So this is necessary to define the force direction. Its mathematical form is this one. Both are same, but only the difference is directional vector. R12 means force exerted by charge Q2 on Q1, and this directional vector shows that force is exerted by charge Q1 on Q2. So this is how we differentiate between the vectorial direction of forces, and we also come to know that which charge is exerting force on charge Q2. This is an assumption. We can replace these prefixes as 2-1 or 1-2. This is on us that how we are taking this assumption. So here we took it as 2 is exerting on 1 and 1 is exerting force on charge Q2. So these both forces are equal but opposite in nature. Their direction is opposite to each other. That means in this Coulomb's law or Coulomb's forces, Newton's third law is in accordance. So we say that Coulomb's force obeys Newton's third law. Newton's third law says that if force is exerted on a certain body, then that body will also exert an equal amount of force but in opposite direction. In short, we say that action and reaction are equal. So this is the vectorial form of Coulomb's law, which is very important, and it is the part of Coulomb's law, and its whole topic is completed when we take this vectorial form. Okay, next thing is the effect of medium. That means as we have discussed earlier that when two charges are placed in space, in air or some other material is placed between the two charges, then that medium will affect the amount of force. Okay, this is a very basic concept. A student should know that what is the effect of medium on Coulomb's force, that force of repulsion or force of attraction. So it is given here that what are the effects. Coulomb's force is reduced when medium is placed between two charges. This is very important, that whenever we place a medium between the two charges, Coulomb's force will always be reduced. The insulating medium between two charges is called dielectric, like Teflon. So formula for Coulomb's force becomes, so if we put a dielectric medium between the two charges, then we have to divide this expression by epsilon r. This is relative permittivity, and there are some materials like air, oil and some other hard material, whether are in gaseous form or solid form, their relative permittivities are given, but here we have only given two, that is epsilon r for air and epsilon r for vacuum. Vacuum's value is 1, and for air relative permittivity has 1.0006. It's a numerical value. Limitation, what is the limitation of Coulomb's law? Coulomb's law is only applied to point charges. We will discuss that what is a point charge or a source charge in next slide, but this is its limitation. It is not applied to larger bodies, it is not applied to bigger masses, it is applied to only very small charges, which are called as point charge. So what is point charge, source charge and test charge? All three definitions we will discuss here. The charges whose sizes are very small as compared to the distance between them are called point charges. It means the charges whose sizes are very small, if let us consider these two charges are there, their size is very small as compared to the distance between these two charges. So this is these charges may be considered as point charges. The charge which produce field is called source charge, and charge which detects the presence of field is called test charge. So if we are taking this charge will produce its electrical field, and that field, how can we find that there is a field? We will bring a negative charge or a positive charge within the field of this charge. So the charge which is brought near the charge which is producing the field is called test charge, and this charge which has produces its field for which we have brought this charge is called source charge. So in short we say that the charge which produces field is called source charge, and the charge which is used to test source charge field is called test charge. So these are the three basic definitions for point charge, source charge and test charge. Often students are confused about their definitions. So again I will revise that point charge are the charges which has very small size as compared to the distance between them, and the source charge are those charges which are used to produce field, and test charges are those charges which are utilized to find the field of any other source charge. Okay, what is electric field and electric field intensity also derive its formula? This is a question, and first we will define that what is electric field. The space or region around a charge within which another charge experiences a force is called electric field. That means if there is a charge placed in some certain region and another charge is brought near that charge or within the field of that charge, then we will experience or observe that the charge which is brought near the field of first charge will experience a force. A force will be exerted in the form of repulsion or attraction on the charge which is brought near the field of a previously placed charge. So it is called electric field. Michael Faraday was the man who given this concept of electric field. He says that there is a space in which a charge has its intensity of field, and that field is called as electric field. Electric field intensity. The force experienced by unit positive charge placed a point an electric field is called electric field strength or field intensity. It means that force per unit charge is termed as electric field intensity. It is represented by A and all E, and its SI unit is Newton per Coulomb. How we find that it is Newton per Coulomb? Force has units Newton and charge has Coulomb, so Newton per Coulomb it is the SI unit, and its mathematical expression is E is equal to F by Q. So it is a vector quantity and direction is along the direction of force. It means E will have the direction along the direction of force. If the force is along north side, then E will also have the same direction along north. So this is electric field, about electric field and electric field intensity, its SI unit and its mathematical formula. Electric field intensity due to a point charge Q. Now we will take a point charge Q and find that how we can find its electric field intensity around in a space around that charge. So the force experienced by charge Q naught placed in the field of charge Q is calculated by Coulomb law, and that electric field intensity is calculated by putting in formula of field intensity. So field intensity formula, we know that E is equal to F by Q naught. Q naught here is the test charge on which the force is exerted by source charge. This is very important to understand, that this force is exerted by a source charge on which charge, which is a test charge, which is brought near the field or within the field of source charge. So if we put the value of F from Coulomb's law, then relationship of E will become like this. E is equal to F by Q naught, and F we have 1 by epsilon naught, 1 by 4 pi epsilon naught Q naught over R square. Here Q is a source charge and Q naught is test charge. R is for direction, and this R is the distance between these two charges. So E will become, when we put this value into this F, then the result will become 1 by 4 pi epsilon naught Q by R square, because here Q naught and Q naught will cancel each other. So it can also be written as E is equal to K Q by R square. So 1 by 4 pi epsilon naught is replaced by constant K. So this is the form. Also there are some other notes. We should know that electric field intensity depends upon three factors: magnitude of charge, that means what is the magnitude of charge, and medium means whether there is air, space or some other dielectric medium, and the third one is distance from charge, and its intensity will be directly proportional to the distance. Okay, if we increase the distance, intensity will decrease. So as we move away from this charge, intensity will decrease. So if we move towards charge, then intensity will increase. That means if distance increases, intensity decreases, and if distance decreases, intensity increases. So it has inverse relationship, and magnitude of charge will affect directly electric intensity. If we increase the magnitude of charge, intensity will also increase. So these are the three main factors on which electric intensity depends. Okay, thank you for watching, dear teacher. This is our channel. Do subscribe to our channel, and we will further move topic wise. Like, share and subscribe our channel. Thank you.